Dear delegates of the Third International Conference, Advanced Technologies in Aerospace, Mechanical and Automation Engineering, I would like to make a presentation of the article called Preliminary Local Thermal Impact as a Surface Quality Assurance Factor. To start with, machine parts used in hostile environments demand increased requirements for the quality of their surface layer. Such parts include piston pins of internal combustion engines, flangers of hydraulic machines, rods of hydraulic distributors and hydraulic cylinders. A feature of the operation of these and similar parts is work in aggressive conditions, under variable dynamic loads and thermal impact of the environment. As practice shows, the fatigue failure of the metal is facilitated by individual defects and irregularities on the surface of the part, which are sources of stress concentration. Submicroscopic cracks occur in the cavities of irregularities during cyclic and alternating loads, which further grow and lead to the formation of fatigue cracks and destruction of the parts. Surface roughness and undulation affect the accuracy of mating of machine parts, contact stiffness, tightness of connections, and other operational characteristics of individual parts and assemblies. It is not recommended to use grinding as a final treatment. On the one hand, it provides the necessary surface quality of the parts, but on the other hand, deteriorates their performance due to numerous micro-defects accompanying this type of processing. Thus, the necessary quality parameters have to be obtained by edge-cutting machining. Worth noting that parts of this purpose are made not only of structural steels, but also of corrosion-resistant, heat-resistant, and alloy steels and alloys, the edge-cutting machining of which has its own specificity. From a technological point of view, it is desirable to obtain flow chip, which is an indicator of the stability of the technological system. However, flow chip can damage the surface of the part that has been already treated with high accuracy and make it difficult to remove chip in an automated manufacturing environment. Thus, it becomes an additional task not only to ensure the quality of the processing, but also to crush the flow chip to facilitate its disposal. The most unstable link in terms of dynamic stability in the manufacturing process of a part during its mechanical operation is the two-workpiece subsystem. Loss of stability in the dedicated subsystem leads to the appearance of a self-oscillating process during machining, which increases the intensity of wear on the cutting part of the tool and reduces the performance of machine mechanisms, which in turn deteriorates the surface roughness parameters and negatively affect the shape accuracy of the workpiece. One of the promising methods to change metal deformation conditions and thus ensure stable suppression of the self-oscillating process at the machining stage is the application of a preliminary local thermal impact on the surface layer of the workpiece in the intended area of removed allowance along a special specified path. The formed local metastable layer on the surface of the workpiece differs in its mechanical properties from the main part of the material, which, at the intersection with the cutting plane, will lead to an instant change in the stress-strain state in the chip formation zone, affecting the properties of the closed, potentially self-oscillating technological system, and thus dynamically stabilizing the machining process. The machining process must be dynamically stabilized in order to ensure the specified values of surface roughness and form accuracy. Let us consider the nature of the proposed local heat treatment method. When thermal radiation interacts with the surface layer of the part along a straight T trajectory formed by moving a heat source at the speed of V, which heats the surface of the part over 720 degrees Celsius, a localized metastable structure is formed with geometric parameters Tm, Hm in the assumed area of the removed allowance. The intersection of the localized heat influence with the surface layer of the part will result in a defect in its structure due to phase reverting reinforcement. This increases the density of dislocation and the tension in the crystal lattice, which contributes to the formation of a metastable structure in the local zone. The subsequent machining step with the set rotation speed of the workpiece N and the feeding of the tool S provides an intersection at the point T. of age of the cutting insert with trajectory of performantly stable structure. The local zone with distorted crystal lattice and mechanical properties different from the main metal volume causes an instant change in the stress-strain state in the chip formation zone. Thus, the process of machining a workpiece that has been subjected to local impact is reduced to periodic changes in cutting conditions compared to the original material, which can significantly change the dynamic stability and boundary conditions of the transition to self-oscillating mode, which will have a positive impact on the state of surface roughness, size accuracy, and geometric shape of the machined part. To form a structure different from the main metal workpiece in the local zone, a device is used that implements the process of applying a local heat-affected line using the electrocontact method with a power of 27 up to 43.2 kilowatts. With the help of the device, a local heat-affected line is applied, along which a phase transition along a straight line is carried out. The depth of the local thermal impact must be less than the depth of the removed layer of material of the workpiece during subsequent processing. Non-compliance with these conditions will result in two negative consequences. Firstly, the treated surface will have local areas with other physical and mechanical properties than the material of the workpiece, which will have a negative impact on the operational properties of the part. Secondly, when machined, the resistance period of the sealing point tool may be drastically reduced, since the top of the tool will be subject to periodic shocks. In order to prevent the negative factors described above in the future, it is necessary to know exactly how deep the chip is to be removed from the surface of the workpiece, and based on this, to set the local heat-affected depth of Tm, which on the one hand would not exceed the removed allowance and on the other hand would ensure a stable chip segmentation. The depth of the thermal impact created by the device depends on two factors: the current delivered to the contactors and the speed at which the device moves relative to the workpiece. The study is carried out when processing the Steel 45 workpiece, allowed the creation of diagrams of the dependence between the influence of current and movement speed of the device, implementing the process of applying a line of local thermal impact on the depth of the formed zone of local impact. Here are the graphs. Similar dependencies can be obtained for corrosion-resistant, heat-resistant, and alloyed steels and alloys with polymorphism, which are used to produce machine parts that operate in aggressive environments and have higher demands on the quality of their surface layers. The graphs created allow the rational assignment of operating modes of the device, implementing the process of applying the local heat-affected line to the surface of the workpiece before its edge-cutting machine, to ensure the specified depth of the local heat-affected line. Application of preliminary local thermal impact will assure the specified quality of the surface of the treated workpiece at semi-finishing and finishing edge-cutting machining modes and stable segmentation of the flow chip. And thank you for your attention.